Okay, so thanks for joining today. I'm April Barton. I may or may not be your official math teacher. There's a couple. We have Karen Whitehead and Janae Russell, but we're all here to help, and we all have different classes. Some of you might be in algebra, some of you might be in geometry. Everyone here is going to be from a different class. Thanks for joining, Selena. If you want your video off, I can turn it off for you, or there should be a button to turn it off. And hopefully you can hear me, hopefully your sound's on. So make sure your chat is open again so that you can answer questions on chat. Today we're going to talk about matrices and determinants. This is an Algebra 2 topic. We'll have time for questions. Then we'll talk about the segment addition postulate. That's a geometry topic, and we'll have time for some more questions. If we don't get to your question or we run out of time, you're always welcome to contact me with questions or contact the teachers specifically for your course. You can email me, you can send people chats. Oh, and we do have some people from financial math. So you're welcome to ask questions from any class. And some of us even have text numbers, so you can text questions while you're working. My texting number, this is not my phone number to call, it's just the number to text. It's 214-801-214-8782. Yep. Okay. So let's talk about matrices and determinants. So this again is a Algebra 2 topic. If it's not relevant to you, you can come in and out. You don't have to stay for the whole hour. We're just trying to reach as many people as possible. And thanks for whoever just joined in. We have a pretty full class today. So matrices are a way to organize a lot of information. They look really weird. It's kind of a new type of math that you don't see as much. And they're used a lot in like computer programming or making video games because you can organize a lot of information at once. So specifically, what we're going to learn about today is how to find the determinant of a matrix. So this is a 2x2 matrix. You learn the rows and the columns to name it. There are 2 rows and 2 columns. So it's called a 2x2 matrix. And to find that determinant, you do basically a kind of cross multiplication. You multiply going in this direction, 3 times 7, and then multiply going in the other direction, 8 times -4, and then we subtract those 2 numbers. So 3 times 7 is 21, 8 times -4 is -32, and that does come up with this minus -32. So what happens when you have a negative right next to another negative? What do we do? What can that change to? And again, you can unmute yourself to answer, or you can type into the chat box.
Add, don't ya?
Very good. That actually changes to addition. This will become 21 plus 32. And that's a good thing to know for any of the classes. When you have a negative touching a negative, that's actually the same as addition. So this would become 53. And that's the determinant. That finds the determinant of that matrix. So we use this determinant to find the inverse of a matrix. When we talk about inverses, it's like knowing the opposite. When we have a positive 3, the opposite of a positive 3 is -3, because 3 minus 3 takes you to 0. Matrices have their own opposites. So it's kind of a weird, complex formula. Like I said, matrices are totally new. They're an Algebra 2 topic, so it's not seen in Algebra 1 or geometry. So when you have this matrix, this is the original. It's called matrix A here. And to find the inverse, we use this formula, a to the -1, that's implying the inverse matrix. So you do 1 over the determinant times, and then you switch a few things around. The A and the D switch spots. And I heard someone else join in, just so you know where we're at. We're currently talking about matrices. This is an Algebra 2 topic. If it doesn't apply to you, we are going to have some question time where you can ask about your specific class. So the A and the D switch spots, and then the B and the C, they just switched signs. It became -B and -C. So if we go to this matrix, and we want to find the actual inverse, its opposite. First, we find the determinant. So to find the determinant, we follow that process of multiplying top left to bottom right. It's like we're going to form an X. So it's kind of like cross multiplying. And if you've just joined, you may have your video on, or you can turn it off if you want. If you don't know how to turn it off, you're welcome to send me a private chat message and I can turn it off for you. So cross multiply 2 times 4, and then subtract cross multiplying in the other direction, 2 times 5. So 2 times 4 is 8 minus 2 times 5 is 10. So 8 minus 10, that involves some integers. When we do subtraction, one number's positive, one number's negative. We do actually subtract 10 minus 8. That gives you 2. But since the bigger number 10 is a negative, we make that a -2. You are welcome to use calculators in any of the courses though. You can use online calculators, you can use handheld calculators, it's whatever you want. I often just Google Calc and use an online calculator. And you may use calculators on the final as well. So if you're not sure about your positive and negatives, use a calculator. They're super helpful. So that's the determinant. So the question said, does it have an inverse? Does it have an opposite? The determinant, if it becomes a 0, if we calculate this all out and we get a 0, that means there's no inverse. If it's any other number than 0, then we can say, yes, this is an inverse. So now we have to rearrange everything according to this formula. The formula says switch the A and the D, switch those spots. So the 2 and the 4 will switch spots. And switch the signs in the other direction. The 2 and the 5 will become -2 and -5. So they didn't change places, they just became negatives. Then we also had 1 over the determinant in front. So basically when you have this number in front, you have to multiply it in to each part. It's kind of like regular old distribution. When you have a number next to some parentheses, you have to actually multiply that number into each part. 5 times x is 5x, and 5 times 10 is 50. So distributing, we get that, and we have the same thing here, but now we're working with fractions. Fractions are kind of hard to work with. And I heard someone else join. Thanks for coming today. Right now we're talking about matrices. This is an Algebra 2 topic. So we have to multiply -1/2 times each thing inside here. We have to do -1/2 times the 4, -1/2 times the -2, -1/2 times the -5, and -1/2 times the 2. So how are we going to do that? Fractions are kind of hard to work with. But this is where our calculator can come into play again. So when you're working with your calculator, you can actually do fractions for your calculator. To do the fractions, we just use the divide button. If we do -1 divided by 2, that's the same thing as the fraction -1/2. So -1/2 times 4 is -2. I ran out of room again, so I'm going to erase some of this scratch work. Maybe. Sorry. Gotta have room to actually write in the final answer. So that first answer was -2. And then we keep going. -1/2 times -2. So depending on your calculator, you do have to be careful with minus versus negative. -1 divided by 2 times -2. This calculator, you just use the minus sign for everything. Some calculators will have a little sign that's negative with parentheses around it. So on a calculator like that, you would use this symbol to make a negative versus using the subtraction to actually do subtraction. So depends on what calculator. Everyone will have a different calculator, so it's hard to give the instructions for each kind of calculator. But again, you're welcome to always send me a message and I can walk you through how to use your particular calculator. So if we multiply the rest out, I'm not going to type them all in, but -1/2 times -5 is 2.5, and -1/2 times 2 is -1. So this gives you the inverse. So I don't think we have time. It was 15 minutes for this. I don't think we have time for this example. If anyone needs this, maybe we'll come back to it later, but let's go ahead and go to the question portion. So for your particular classes, what are some questions you have in your courses? You can unmute yourself to ask, or you can just type into the chat box. What are some questions you have for your math courses? I'll keep looking for questions. While we were waiting to start, we had a question on polynomials, so I can talk about that for a little bit. But you're still welcome to type in a question to the chat or unmute yourself and ask a question. So polynomials, I'll talk about polynomials again, and I'll just keep an eye out for any questions. We talked about, while we were waiting for people to join, about how to name a polynomial. You are also asked to add polynomials and multiply polynomials. Oh, I totally spelled that wrong. Sometimes when I'm talking, I can't also spell polynomials. So this is an Algebra 1 topic, semester 2. So polynomials, if you're asked to add or subtract them, you're going to be asked to combine them together. Thanks for joining. Right now we're in the question section. I'm talking about polynomials, but if you have a question for your specific course, feel free to type it into the chat box or unmute yourself and ask, and we can get to it during the question portion. So polynomials, this is an Algebra 1 Semester 2 topic. If you're asked to add them together, there will be a plus sign between two different polynomials. Naming it wise, this is another quadratic trinomial. Highest degree is 2, so it's quadratic. There's 3 terms, so it's a trinomial. And this one is a quadratic binomial. Highest degree is 2, so it's still a quadratic. And there's 2 terms, so it's a binomial. So when they ask you to add, you're basically combining like terms. You're taking the things with the same variables and the same exponents and combining those things together. One way to remember your like terms is actually to think about how these are said out loud. If I say 3x squared because the little 2 versus 8x, those are not like terms because 3x squared is different than just 8x. So what is the like term for 3x squared? What other term is also x squared? And I did have another question. We'll get to it when we're done with polynomials. So what are the... What's your like term to 3x squared? And I'm going to go ahead and mute whoever's microphone is on. Unless you're going to answer a question, let's keep you muted so there's no background noise. It's our like term to 3x squared. Where's the other x squared in either polynomial?
Is it 11 too?
The 11x2. That's the like term. Very good. Because they're like terms, we can actually combine them together. 3x squared plus 11x squared is 14x squared. We have one thing that's an x squared. We have the other thing that's an x squared. So it's like saying, well, I have 3 apples and 11 apples. Total, I have 14 apples. So this is 14x squared. So there's our first like term. What about our 8x? What like term do we have for 8x? And it is kind of a trick question. Okay, so since I don't have any answers yet, I'll go ahead and tell you. 8x, there is no like term. Nothing else has an x in it. So our 8x just goes next to it, plus 8x. If there's no like term, it shouldn't just disappear, but we just bring it down as part of the answer. So then our final one is the -10 plus 7. And that gives us -3. So once you combine those like terms, that's our final answer. So I also had a question about how to do rate of change and slope. This is another algebra topic, but I believe it's in semester 1. So rate of change is usually the change of something over time. If you have ever driven, which most of you probably have, then you know that your speed limit is in miles per hour. 5 miles or 50 miles per hour or 65 miles per hour. That's actually a rate of change. That's rate of distance, or change in distance, sorry. Change in distance over change in time. So to make that a little more concrete, let's say you haven't started driving yet, so you're not going any speed. You've got no distance, you've gone 0 miles, and no time. 0 time has passed, 0 hours. But then let's say you drive for 2 hours and you've gone 100 miles in 2 hours. You can find the change in distance by subtraction. The change in distance, I totally put this upside down. Sorry, this happens when I try to make stuff up on the fly. No, change in distance over change in time. Sorry, I'm trying to make sure I have this in the right order. It should be the y values over the x values. We definitely want to divide by time. So I think I switched this order. It should be 2 hours and 100 miles. Let me fix that. Okay. So we're going to have hours first, miles second. So to find the change in distance, you do subtraction. You take the final distance minus the original. And since we didn't have any distance at first, that's just 100 minus 0. To find the change in time, you do the same thing. You do subtraction, 2 minus 0. So that would give us 100 over 2, and then you actually do the division to get 50 miles per hour. So we're actually finding some sort of rate. That's why it's called rate of change. But it's not always an application type problem. Sometimes they just give you 2 points and say, find the rate of change. So this is where we have to go to a formula type process. So formula-wise, you saw me write up briefly y2 minus y1 over x2 minus x1. Just trying to give you the general idea first, and now we can just apply it to the formula. So this is actually a change. Subtraction is the change in whatever over the change in whatever. If they don't actually give you distance or miles, they just give you numbers, we've got to just plug them in. So how do we know which number goes where? Well, every single coordinate is an x, then a y. They're always alphabetical, and they always start with the letter x, then the letter y. But we can't actually keep them just 2 x's and 2 y's. They're different. This x is a 3 and this x is a 15. So we say the first point is x1, y1 because it's the first point. And the second point is x2, y2 because it's the second point. So once you've identified that, now we can go plug these in. We can actually substitute the numbers into the formula. And this is the rate of change formula or the slope formula. That's actually 2 different words for the same thing. Rate of change and slope both use this exact formula. So what number are we going to replace y2 with? What number is the y2 value?
$24.
Good, 24, thank you. That is correct. That's the y value of the second point. So that's y2. Okay, what do we put in for y1?
8.
Good. 24 minus 8. So then we do the same thing with the x's. 15 minus 3. Now we actually do that subtraction. So with fractions again, we have that division bar. You have to do everything on the top separately from everything on the bottom, and then worry about the division. So we're going to do the actual subtraction. 24 minus 8. And then the 15 minus 3. And again, use the calculator if you want to. They're super helpful. So then we can worry about the division. Some of them will just outright divide. But if we do 16 divided by 12, let me do this again. 16 divided by 12, that gives you a decimal. Slope is never a decimal. Some problems you'd be fine getting a decimal, you could be done. This one, we don't want it as a decimal, but we do want it as reduced as it possibly can be. So we want to say, is there any number that divides into 16 and also into 12? What number divides into 16 and also into 12?
4.
4. Some of you might have thought 2, which is correct. 2 does work. We want to pick 4 though because it's the bigger number. And then we do that actual division. 16 divided by 4 is 4. 12 divided by 4 is 3. So if they give you 2 points, you just plug it in. This same formula is used for tables and for graphs. If you're given a table, oh, I ran out of pages. I'll just erase this page and use this same page. If you're given a table is just a list of points. So if you're given a table, you're still using the y2 minus y1 over x2 minus x1. But they've given you extra points. You have extra information. We're going to just pick 2. And usually I just pick the first and the second. These are actually just coordinates. It's the coordinate 1, 4 and the coordinate 2, 7. So once you know the coordinates, we just go through the exact same process. We say every coordinate is x, y. One of them is the first point, one of them is the second point. And it actually doesn't matter. If you had switched the order and you wrote 2, 7 first and then 1, 4, you're going to come up with the same answer. Just make sure 1 point is the first point and 1 point is the second point. Then we just plug it in. So what would we do for the top? What numbers make the top of this formula?
Seven and 4.
Good.
7 minus 4.
7 minus 4. And then on the bottom, 2 minus 1. So then you just do your subtraction again. 7 minus 4 is 3. 2 minus 1 is 1. And we do the division this time. 3 divided by 1 doesn't come out as a weird decimal. So you can just say 3 divided by 1 is 3. So this time the slope is 3. Or the rate of change. Again, those are just 2 different words for the same thing. So if it asks for rate of change, you do this formula. If it asks for slope, you do this formula. The last thing it can apply to is a line. Oh, I keep forgetting that I don't actually have an extra page. So they can give you a graph. With an actual line on it and asks what is the slope of this line, or what is the rate of change of this line. Sorry, it takes a little bit to draw a picture. So if they gave you an actual picture, if the coordinates are not labeled, you have to figure out what is the actual coordinate for some of these points. And we determine that from counting from the center of the graph. The x-coordinate is always how far left or right you count. The y-coordinate is how far up or down you count. So from the center, to get to this coordinate, I count right 1, 2 spaces, and down 1 space. So 2, -1. This coordinate, we always go back to center and start counting again. I go left 2 spaces, that's a -2, and up 1, 2, 3 spaces, that's your 3. So once you've identified those points, it's the exact same process. All of them come back to that formula, y2 minus y1 over x2 minus x1. So something to watch out for on this one is that we might end up with that negative happening again. We do y2 is -1, minus y1 is 3, but then on the bottom we'd have x2 is 2, minus x1 is -2. Since this is a negative, but the formula had a minus, we have 2 of them. We have 2 minus -2. And we saw before what happens when you have a negative directly next to a negative. What's that change to?
A positive.
A couple people answered and you're both right. Plus, changes to plus or a positive. So this is -1 minus 3 over 2 plus 2. So even though this had 2 minus signs, they weren't touching. There is a 1 literally in between those 2 signs. They have to be directly next to each other. So then we combine the top, combine the bottom. -1 minus 3. Oh, got to clear out my calculator. Is -4. And 2 plus 2 is 4. So then I always try dividing first. Maybe it's a fraction that needs to be reduced. Maybe it will just divide. So -4 divided by 4, -1. Just divided. So that is our slope. My whiteboard is not letting me write for some reason. I'm going to have to refresh the page. I don't know why it's not currently letting me write. So that's rate of change in slope. While the whiteboard's refreshing, we are going to talk about segment addition next. This is from our geometry class. Let's write the final answer for this though, -1. That's the actual slope. So segment addition, this is from our first quarter of geometry. If you're in Algebra 1, you'll probably have to take geometry at some point. If you're in financial math, you may or may not, depends on what credits you've already earned. That you would have to ask your academic coach. They're in charge of what actual classes you take because they know what you've already earned, and so they know what to put you in next. So segment addition, it's basically just addition or subtraction, at least when there's no variables involved. Kind of depends on what they give you. So segment addition, they'll take a line segment and they will be split into some pieces. And this time we were given 2 pieces and it said find the length from S all the way over to U. They want the entire length. So if you have 2 separate things and you want to know the entire amount, Like if you had a $5 bill and a $10 bill, you'd say, well, I have $15 total. You add those two pieces together. That's the same for segment addition. The first piece, ST, plus the second piece, TU, that will give you the entire segment. That will give you all the way from S to U. They can also give you the entire piece and then part of the line, and they want the other piece. If we want the length from S to T, what should we do with the 20 and the 8 to get that little piece?
When you subtract,
Good. This time we subtract the two numbers. So 20 minus 8 is 12. So then what can make it more confusing is involving some variables. We're going to actually have to set up an entire equation this time. And if you're in algebra, this is still going to be good practice because you have some solving equations questions. This will be solving an equation after we set it up. So usually there's some information in sentence form. Point B is on line segment AC. They're just saying there's a point here. If AB is x plus 5, which is already labeled, and BC is x plus 11, also already labeled, and A to C is 26, then find the value of x. So when we did the first problem, we said the 10 plus the 6, that equals the entire amount. Each piece added together equaled the whole thing. That is the same here. X plus 5 is one piece, plus the x plus 11 is the second piece. That equals the entire amount, the 26. So the actual setting up of the equation, that's a geometry topic, knowing take those two pieces, add them together, that's the geometry. The algebra is going to be actually solving this equation. We just had someone else join, so just to catch them up, we're talking about geometry right now, the first semester of geometry. This segment addition postulate is the name of this. But now to solve it is some algebra. So when you solve an equation, you always look at the two sides. We have the left stuff to the left of the equal sign, the stuff to the right of the equal sign. And you want to check for two things first. Is there anything to distribute? That's when you have some parentheses, but we don't. And are there any like terms to combine? So on our left side, what like terms could you add together because they're in
X.
Okay. Good.
And then 5 and 11.
Very good. The x's and the 5 and the 11. So the x's don't currently have any numbers attached to them. When there is no number actually in front of the x, what number is it?
1.
Good.
1.
Good. You're also correct. 1. So when it's a 1, we just do 1 plus 1 gives us the 2x. So then the other like term were the 5 and the 11 because they don't have variables. And that gives us 16. Positive 5 plus 11 is 16. So once you've combined like terms, now you start doing your opposite operations. We want to move everything away from the x that we can. So almost always we do the opposite of addition or subtraction first. So what's our opposite of adding 16?
Subtracting 16 from both sides.
Good. Subtracting 16 from both sides. So some people like to write it with the minus 16 on both sides. They like to see these actually cancel each other out because what is 16 minus 16?
0.
0. We wanted that to become 0 because 0 goes away. Some people don't like having that much writing. It makes it kind of confusing. So some people just say, I'm going to minus 16 over here, and I'm going to cancel out the 16 because by doing the opposite, that actually gets rid of the number. So 26 minus 16 is 10. So what's our last opposite? What's the opposite for that 2?
You have to divide it on both sides.
Division. When there's a number next to a letter, this was multiplication, but they don't write it. They assume you know a number touching a letter is multiplying, so the opposite is to divide. And again, by doing the opposite, it cancels it out, and we just get our final answer of 5. So that's pretty much all for the segment addition. So we're back to questions. Everyone's in a different class, but you can ask questions for any of the classes. What would you like to hear more about? And you can unmute yourself to ask a question, or you can type into the group chat. I was trying to say group and chat and said group chat. If you haven't opened your chat box, there should be, mine shows 3 dots. Wherever your menu is for your Zoom, you can open a group chat and ask questions there too.
What about that reflections? I didn't really get to know what that meant in the first part of algebra.
Reflections in algebra?
I think it was.
Okay, well, let me double check.
Pretty sure.
Yeah, it's week 4, the reflections for week 4 in algebra semester 1.
Oh, you mean like when you,
Too.
sorry, go ahead.
I said I struggle with that too.
So the reflections where you have to actually answer a question and type stuff in?
Some of it, yes.
Okay.
Yeah.
So let me bring up, can everyone see the algebra course on the screen now?
Yes.
Yes.
So this kind of part where it asks you some questions.
Yeah, some of that, yeah, the discussion board.
Okay. So usually there's a specific question. What has been your favorite lesson or activity in this course and why? Think back to an activity that was difficult for you at first, but then you were able to learn how to solve the problem. How are you able to solve the problem? Or finally, where do you feel you still need extra practice from the past 2 units or from other parts of the course? So this whole box area, this is just to tell you this is how it's going to be graded. If you answer all the questions and you use 3 or more complete sentences, that gets you full points for this first part. If you only answer 2 questions and you still used complete sentences, that only gets you some points. And if you only posted like 1 sentence or no sentences, then you don't meet yet. You are also asked to comment on another student. That's worth a lot less. If you don't make a comment on another student, you're not going to lose all your points, but you will lose a few. So this is from my perspective. It might look a little bit different than yours. I'm not sure I can actually type anything in. Oh, I think I can. Okay. So for me, I think I hit this new thread. Yep, and it'll bring up a box. And then you specifically answer the questions. If you can't remember them, like me, you'd want to scroll back up and read it again. What has been your favorite lesson? And this is very subjective. There's no wrong answers. As long as you answer, then you get points. You know, my favorite lesson was mean, median, and mode. And then you could say why. I liked it because I'd already seen it before and I was comfortable with it. Or maybe you didn't have a favorite lesson. Just say, I didn't have a favorite lesson because blah. Does that make sense? Any more questions on this?
Yes, there's one more.
Mhm.
Okay, when you see where it says that Ashley up there at the top on your,
Yeah. Yep.
okay, now this is before I knew. I had somebody help me with this. I did not know I was supposed to go to the arrow over here, and that's how you comment on theirs, right? The first arrow there, to your right.
To my right.
There at the
This arrow?
corner, underneath the thread.
Oh.
See, I didn't know I was supposed to
Okay.
comment on that, and I thought, oh no.
Okay. So, yes, you do have to hit the arrow to reply so that you actually reply to other students' comments.
Okay.
Okay. Thank you for pointing that out. I'm still a little unfamiliar with this discussion post because it's pretty new. It's something we just started. And then if you wanted, you could attach a file. I don't think that's going to be useful very often. And then if you decide you want to answer later, you can hit cancel and say, yes, I want to just discard my post and not worry about it. I do try to, if you've lost a lot of points, like you didn't fully respond, I do try to set it to retry. You can redo any assignment you want, as long as it's below an 80%. If you have a 90%, that's a good enough score. You don't need to redo it. But if you have a low enough score and you want to retry it, you can always send me a message or your teacher. Everyone has different teachers. And we can set it to retry so you can bring your score up. If you're not happy and you want to bring your score up, just let us know. Okay, anything else? What else would you guys want to ask about?
So I'm calling from Achieve Point Career Academy. We are a new community tuition-free school opening in your area. And are you interested in?
You look fine.
We did have someone from financial math, so we could talk about a financial math question if anyone has a financial math question.
So that really just depends on how many credits you still need.
Feel free to keep asking questions. I'm going to go ahead and talk a little bit about financial math until I see a question or hear a question. So in the financial math class, you're asked to use this mortgage calculator. There's a unit on buying homes. So when you buy a home, it's good to figure out how much am I going to have to pay per month? How much interest do I actually pay to a bank? And so we use this mortgage calculator. So it will give you a cost. It'll say you're going to buy a home for $250,000. So the amount you're buying the home for, that's your home value. Then it'll say whether you're making a down payment or not. Sometimes you pay money up front and you say, I'm going to pay $20,000 because that's less money I don't have to actually borrow. So the down payment, you type it in. On the mortgage calculator, it automatically calculates your loan amount. You never have to type in the loan amount because this mortgage calculator does it for you. Okay. So the person in financial math has not made it that far yet. Still good to see. So I'll finish up talking about it, but I think it's in semester 2 actually. So if you have a different question in your class, though, I'd be happy to answer any questions you do have in the financial math. Interest rate, they'll just outright tell you. They'll say, you know, it's 3.5%. They'll tell you how many years. Most people, it's 30 or 50 years, or sorry, 30 or 15 years. And then usually it just says to leave the rest the same. And then you just hit the calculate button. And there will be a whole bunch of information on the right that you have to figure out what they're asking for. A lot of times it will ask for total interest paid. So that's one number. You actually pay that amount of extra money. Interest is what you pay to the bank. So in order to borrow that much money, the bank is like, well, over that 15 years, you're going to end up paying us almost $66,000. That just goes to them. You never get it back. Total taxes paid. That's estimating how much money you pay to the government to own your house. And then total. So even though the house was only $250,000, in total you end up paying $350,000, some to the bank, some to the government, some to insurance. Houses are expensive. And then payment-wise, when you get a mortgage, you have to pay the bank a certain amount every month. So that's a number that you'll see a lot when it asks. Yeah. So anything else? What other questions do you have from your courses? Not sure what assignment this is, but I am doing Algebra 1 Semester 1. They had a question, what is the constant of variation for the following table? Write your answer in the form of a fraction. Constant of variation. It sounds like rate of change. Let me look at the Algebra 1 course really quick. Algebra 1, Semester 1. Constant of variation. Solving equations, inequalities, graphing. I wonder if this is direct variation. That's what it's probably. Rate of change. There we go. Okay. Direct variation. So, direct variation is a very specific type of line. It's this y equals kx formula every time. Direct variation. And it's a specific line in that when it's graphed, it always goes through the center. It can be tilted or turned another way, but it's got to go through the center. As soon as the line's not in the center, that's not direct variation.
Orgy, you better watch out. This will hurt. It does a little spit.
Did you have a question you wanted to ask? Because there's a lot of background noise. Okay, sorry, I muted you. If you have an actual question, feel free to ask, but there's a lot of background noise, so I muted you until you actually ask a question. So it said specifically from a table. So you'll have a table. And they want the constant of variation. So they want this k. They basically want the slope or the rate of change. So you technically could use the slope formula, but since we know direct variation is always this y equals kx, we can use one of the points and plug it into the equation. So the first column is x, so 2 is our x value, and our second column is y, so 10 is our y value. So in this formula, y equals kx, we can plug in 10 for y and 2 for x. So now we solve for k. How do we get k alone?
Okay, don't we divide?
Good. You divide by 2. And the one side cancels. The other side, you just do the division and get 5. So if your answer is a fraction, leave in the form of a fraction. This one, it's not a fraction. It comes out, it's just 5. let's say our table was, oh, and I'm going to go ahead and put you back on mute. Again, there's just so much background noise. We have to keep you muted until an actual question or you're actually speaking. So let's say our table was, let's say this was our table. Sorry, this value should have been 9/2. So you do the same thing. We still plug in our x, we still plug in our y into this y equals kx. This time our y is 4, and our x is 8. So this time when we go to divide, when we divide by the 8, now we don't get a nice number. 4 divided by 8 gives you a decimal, 0.5. So this is where if your answer is a fraction, leave it as a fraction. You do want it simplified. So what's the biggest number that divides into 4 and also into 8? It's the biggest thing that divides into 4 and also into 8. So what do you think? Biggest number that divides into 4 and into 8? Haven't heard any answers so far, but the biggest number is a 4. 2 divides into both of them, but the biggest one is 4. So 4 divided by 4 is 1, and 8 divided by 4 is 2. So the constant of variation is 1/2. So we have one more quick question. I had a student say they wanted to know more about functions. Discussing what a function actually is will take too long for the time we have left. We're almost out of time for today. These always go for about an hour. But using function notation, we can talk about in enough time to finish. So when you're given a function with this f of x notation, the purpose of a function in this notation is that they can tell you how to, or they can tell you a value to plug in just using this function notation. If I write f of 4, this is saying plug in 4. So wherever you see the letter x, we're going to replace it with the number 4 and then simplify. When you've done your replacing, when you simplify, you have to follow order of operations, parentheses, exponents, multiply, divide, add, subtract. And that just tells you the order to do stuff in. Math is not always left to right. It goes in order of do any parentheses first, do exponents. So we have multiplication and we have subtraction, but we do the multiplication first. 3 times 4 is 12, minus 5 is 7. So when it asks you to find f of 4, it's just saying plug it in and get that one number as an answer. If they made it a little more complicated, They could ask you to find f of 5, and that still just means take the 5 and plug it in and simplify. Everywhere we see an x, we're going to replace it with a 5. So it looks almost exactly the same, but now we have 5s in each of the spots for an x. So order of operations again, we have to figure out, well, what do we do first? So we think of PEMDAS again, that's just the order. We don't have parentheses, but we do have an exponent. So some people like to do the 3 times 5 first because we really want it to work left to right. It's how our brains are taught to work because that's how we read. But we actually do the 5 squared the very first because it has an exponent. And exponents come before multiply.
Hi, this is Angelique.
So 5 squared is 25.
My name's Katie. I'm calling from Achieve Point Career Academy.
So now we've done the exponent, we can move on to multiplication. We have a 3 times 25 and a 2 times 5. So 3 times 25 is 75, 2 times 5 is 10. And then the addition and subtraction, you can go left to right. You don't have to do the add first. When it's only addition and subtraction left, we just do 75 minus 10 plus 4 is 65 plus 4, so 69. So we are out of time now. If you have more questions, feel free to contact me or contact your teacher. I'm going to put my contact information
Thank
up
you.
again. You're welcome. Thanks for joining me today. You can email me.
Yes.
Yep. You can email me, you can text me, you can chat. And it was really great to help you guys all out today. Have a good day.
You as well.